Hey everyone, welcome back. Welcome to another exciting video on system design. In this video, we are going to discuss about the design architecture of one more interesting system, which is Twitter. So let's get started and understand the overall design architecture of Twitter system. So you can see a diagram on the screen. It seems quite complicated right now, but after watching this video, you will have the enough understanding of this diagram and all the tech jargons that are mentioned here. So let's get started and understand the functional requirements and non-functional requirements of our Twitter system. So the very first thing that user will be doing is posting a tweet. So this tweet can be anything. It can be image or video, it can be plain text, or it can be a long URL, or it can be a short URL. So these are the different varieties of tweets that user will be posting. So this is about our first functional requirement, posting a tweet. So here user will be posting a tweet and he will also be retweeting a post. So we will provide both the functionalities to user. The next functional requirement that our system will have is follow someone. So we are going to provide this functionality as well, through which one user, let's say user 1, can follow some another user, let's say user 2. So we are going to provide this functionality as well, and this functionality is going to be unidirectional. Now what does that mean? So let's say this user 1 follows user 2. That doesn't mean that this user 2 follow this user 1. So this is the meaning of unidirectional, and this is about our second functional requirement. Next functional requirement that our system will have is timeline. So in this Twitter system, we will be managing two types of timeline. First is a home timeline and second is a user timeline. So let's try to understand home timeline first. In home timeline, when you will open a Twitter system, you will see a home page, and in that home page you will see all the tweets made by the users that this person follows. So let's say here we have user 1, and this user 1 follows user 2, user 3, and let's say user 4. So in the home timeline of user 1, we will see all the tweets made by user 2, user 3, and user 4. So this is the meaning of home timeline. Now what is this user timeline? So when you will open someone's user timeline, you will see all their tweets, you will see their profile picture, their username. So you will see all such information, and this user timeline would be specific to particular user. Let's say for user 1, this user timeline would be different. For user 2, this user timeline would be different. For user 3, this user timeline would be different. Now how we will access someone's user timeline? So we will discuss this after some time. So this is how we will manage home timeline and user timeline. So this is about our third functional requirement. Next functional requirement that our system will have is trends. So we will be calculating trends in our Twitter system. What all the keywords are trending, what all the hashtags are trending. Let's say there's a World Cup final match between India and Australia, and India left that World Cup. So hashtag India will be trending, hashtag World Cup will be trending. So we will see how we will calculate different trends. So this is pretty much for our functional requirements. Now let's discuss a little about our non-functional requirements. So Twitter is going to be a read heavy system. For every single write operation, there will be 1,000 read operations in our system. That means every single tweet that is posted in our system, there will be 1,000 people reading that tweet. So Twitter is going to be a read heavy system, so we will have to manage this. The next non-functional requirement would be availability. So our system and all the services really needs to be highly available all the time. There should be almost 0% downtime of our system. So this is about our second non-functional requirement. Next, we don't need strong consistency here. Now what does that mean? So let's say if user posted something, okay, let's try to understand this with the help of example. So let's say here we have this user 1 and user 2 and user 3 follow this user 1. So when this user 1 will post something, this user 2 and this user 3 will see that post and will see that tweet. But let's say if both the users, user 2 and user 3, watching his tweet, let's say after 15 minutes, so it is fine and there's no harm in that. So eventual consistency would be good enough for system like Twitter. So this is about our third non-functional requirement. Next we have fast tweet and fast rendering. Now this is about our fourth non-functional requirement. So when someone will post a tweet, that tweet should be immediately come in our system. So a tweet should be uploaded very fast in our system. Let's say someone is in a very good network area, so he will click on upload button. The moment he will click on upload button, that video or that tweet should be immediately uploaded in our system. So this is about fast tweet. Now what is this fast rendering? So we discussed about home timeline. In home timeline, people will see all the posts and all the tweets made by other users that this person follows. Let's say this U1 follows U2, U3, U4. So in the home timeline of U1, he will see all the posts made by this user 2, user 3 and user 4. So the moment this user 1 will open his home page, that page will be rendered very fast and he will be able to see all the tweets, all the relevant tweets. So this is the meaning of fast tweets and fast rendering that will together make non-functional requirement, which is low latency. Low latency means server should respond to users request in a minimal time. So this is about our fourth non-functional requirement. Next we have easy to scale. So Twitter is a very read heavy system in which we will be having millions of users, millions of read operations per day. So we will have to scale our system. We will have to scale different components. So everything should be horizontally scalable. And in order to scale properly, database choice would be very important. So we will be discussing database choice as well, for what service, what database we are going to use. So we will be covering everything. So this is pretty much for our non-functional requirements. Now let's discuss about some of the ballpark figures to make database choice and further design of our system. So Twitter has roughly 250 million daily active users. That means 250 million users using Twitter every day, and Twitter has 600 million monthly active users, which is obviously a large number. Then there are 6,000 new tweets coming on Twitter per second. That means Twitter is going to be a write heavy system. So it is very obvious that we are going to store massive amount of data every day. And in order to store these tweets and massive amount of data, we need a data store that can easily manage such huge volume of data. So we will be using Cassandra for that, and we will be using S3 storage or CDN. So depends on the tweet type, we will be using different data store. Now we have already discussed about the read heavy behavior of Twitter, that Twitter is going to be a read heavy system. For every single write we have 1000 read operations. That means every tweet that is posted, there are 1000 people reading that tweet. So you can see this line here, that Twitter has 1000 times more read traffic than write traffic. So if people are posting 6000 tweets per second on Twitter, that means there will be 6000 into 10 to the power 3 people reading that tweet. or we can say that in a second there will be this amount of tweets will be read. So this is about some of the ballpark figures, and these ballpark figures tells that Twitter is a read heavy system, Twitter is a write heavy system, and in order to scale this we will have to make database choice very smartly, very efficiently, and we will also design its architecture very smartly. Now let's discuss the overall design architecture of Twitter. We will be discussing about different components. So you can see a diagram on the screen, and in that diagram you can see different components, some in green color, some in blue color, and some in this color. So we have different components. Now let's discuss what each component does and what's the work of these components. So all the components available in green color would be user interfaces through which user will interact with our system. So components available in green color would be user interfaces. Then here we will be having load balancers. These load balancers are also reverse proxies and authentication and authorization layers. So this is about load balancers. Next we have components available in blue color. These will be different services of our system. These services can be our REST APIs, REST services, in which we will be covering search service, we will be having tweet service, we will be having timeline service. So we will be having different services, and all the components available in this color would be either databases or Kafka consumers or other open source tools that I used for this system. So control starts from this UI for login, through which user enters to our system, or we can say that he will log into our system. So this UI is our login window, and it will be responsible for onboarding user to our system. Now here we will be having this user service. So this user service will be the source of truth for all the user related information. User will be having his username, password, email address, phone number, and other information. So all such information will be powered by this user service. This user service will also have the functionality of login and sign up. So if someone wants to register themselves, they will talk to user service, and let's say if someone wants to log into our system, then user service will provide the login flow. So this is about our user service, and this service will be the source of truth for all the user related information. So other service will talk to user service. Now why other services will talk to user service? Because let's say this graph service wants the detail of a particular user, so this information will be powered by this user service. So this is the reason this graph service will talk to user service. So this is pretty much for this user service. Now this user service is sitting on top of MySQL database. Now why we are using MySQL database here? Because here data is going to be very structured. We will be having user ID, username, password, phone number, and other user related information. So data is going to be very well structured, and there will be relation between different entities. So data is going to be very relational. So data is going to be very structured, and it can be present in the form of tables. And even if there are 100 million plus users in our system, but still this MySQL database will be able to handle this amount of traffic and will be able to handle this amount of users. So MySQL database would be a perfect choice for this user service. Now we are also using Redis cluster here. Yeah, before talking about Redis, let's first discuss the APIs that this MySQL database will offer to user service. So user will be changing his information, not very frequently, but some of the users might be changing their information. So this MySQL database will provide some of the post APIs. Now let's discuss what kind of APIs it will provide. So API can be this, update email, update username. So all such APIs will be provided by this MySQL database. Now this MySQL database will also power some of the GET APIs, and these APIs will look something like this. So we will be having get user by email, or we can say that we will be having one more API, get user by user ID. So these are the different APIs that this MySQL database will offer to user. Now this MySQL database will provide some of the bulk get APIs as well, because let's say you want to fetch someone's follower. So instead of fetching every single follower one by one, we will get all the followers in a single go. Because if we will query user service for each and every user, then it will obviously a bad thing, and it will increase the latency a lot. Because let's say someone has 1000 plus subscribers, 1000 plus followers, so in this case you just cannot query user service for each and every user. So this is the reason this MySQL database will provide some of the bulk get APIs. So it will provide bulk get API. So this is pretty much for this user service and MySQL database. Now here we are also using Redis cluster. Now why we are using Redis cluster here? Because as we already discussed that this user related information is not going to be changed very frequently. So we can store this information in Redis, because we already discussed that Twitter is going to be a read heavy system where we will be having a huge read traffic. So if our system is read heavy, then it is very good to pre-calculate some of the information or cache some of the information. So this is the reason we are using Redis here. And we have also discussed why we are using Redis for user service, because user related information is not going to be changed very frequently. So this is the reason we are using Redis here. Now let's see what kind of information we are storing in our Redis cluster. So first we will be storing user details, as we already discussed, and we are also storing the information about followers of user. So we are going to cache this information as well. We will be caching users following, and we are also going to store the type of the user. Now we have two different types of user. First is active, who is active in Twitter, or we can say who is accessing Twitter in the last 3 days. So this is about our active user, and here we will be having one more user, and we call this user as passive user. So these users are the one who did not access Twitter for the last 3 days. So this is about the type of the user. Now we are also going to use user's last access time, because on the basis of this we are going to calculate we are going to identify who is the active user and who is the passive user. So last access time is also very important. So we are going to store this information in Redis, where key will be the user ID, and value will be the object of this type. So this is pretty much for the user service, MySQL database and Redis. Now let's discuss the flow, how they interact with each other. So let's say a user came to our site and he wants to get a detail of a particular user, or let's say he wants to get detail of his own profile or own Twitter profile. So request will come to user service. Now first user service will query Redis cluster for user related information. If that information is present in the Redis, then Redis itself will serve the user's request. And let's say if data is not present in the Redis, then in this case this user service will go to MySQL database and then MySQL database will serve the user's request, and it will also store this data in Redis cluster for future reference. So this is enough about user service. Now let's discuss a little about this graph service. So this graph service will be responsible for follower and following thing. Let's say we have two users, user 1 and user 2, and both the users follow each other. So here we will be having two users and they follow each other. So in this case, both the users can be represented as a vertex, and these edges that represents their relationship, who follow whom. So this will be represented as edge. So you can consider this as a directed graph kind of a relationship, and this is the reason we named this service as graph service. So this service will be responsible for following and follower thing. Now this graph service is also sitting on top of MySQL database, because here also data is going to be structured and very relational, because there will be relationship between different entities. There will be relationship between follower entity and following entity. So data is going to be very structured, very relational, and it can be present in the form of tables. So this is the reason we are going to use MySQL database for this graph service. Now this MySQL database will manage more data as compared to this MySQL database, because this MySQL database will be managing follower and following thing. So we can think of sharding the data. So yeah, this is pretty much about graph service. And one more thing, we are using Redis here for graph service. Now what is the need of Redis here? So in Twitter you will be following different users and they will follow you, but it is very obvious that you are not going to add new people every day. That means this data, this follower and following data is not going to change very frequently. Although for 100 million users, or let's say 200 million users, this data is going to be changed, but for half of the users, or we can say 50 million users, this data is not going to be changed very frequently. So this is the reason we are going to use Redis here. So we will be cache this follower and following thing. We have already discussed this here, that we are going to cache this data where key will be the user ID. So this is the reason we are going to use Redis here for graph service. Now one more thing, that this MySQL database will power some of the GET APIs to graph service. It will be related to follower thing, or it will be related to following thing. Let's say if one user, or we can say that some user wants to fetch someone's follower, or we can say that he wants to fetch someone's following. So this MySQL database will provide these GET APIs, get follower by user ID, get following by user ID. So it will provide different bulk GET APIs to get someone's follower or someone's following list in a single go. So this is pretty much for this graph service. Now let's discuss about the major part of our system, that how tweet will come into our system and how it will go through with different services, and how we will store that tweet, and how we will send this tweet in different followers timeline. So control starts from this upload UI. Through this upload UI, user will post their tweet, and then tweet will come to Twitter system. Now this tweet ingestion service will grab that tweet, and we have already discussed that tweet can be of different types. This tweet can contain video or image, or this tweet can contain a plain text. This tweet can be a long URL. So we can have different tweet types. Now let's say if that tweet contains video or image, then we will handle it separately. If that tweet contains long URL, then we will handle it separately. And if that tweet contains plain text, then we will handle it separately. Basically we will store them separately. So let's say if that tweet contains video or image, then this tweet ingestion service will send that tweet to video image service. Now we have already discussed about Netflix system design. So entire implementation of this video image service will be based on the Netflix system design, in which we will be discussing about how we are going to store tweet, how we are going to store video in S3 storage and CDN, then how we will fetch that video. So entire implementation of this video image service will be based on Netflix system design. So I made a video on that, so you can watch that video if you want to understand the implementation of video image service. Now let's say if that tweet contains long URL, so we can handle it separately, and in order to handle it separately we are going to use this tiny URL service. Basically this tiny URL service will convert that long URL to short URL, and it will provide us that short unique URL. So if that tweet contains long URL, we are going to use this tiny URL service. I have made another video on tiny URL system, so if you want to watch the implementation of that, please go and watch that video. Now we have only one thing left, which is the plain text. That means if tweet contains plain text, so how we are going to handle that? So as we already discussed that Twitter is a write heavy system as well. There will be 6,000 tweets come in Twitter system every second. So in order to store those tweets or metadata of tweets, we need a database that can store huge volume of data. So in order to store the tweet metadata, we are going to use this Cassandra database. So we will be storing everything, hashtags, keywords, text of the tweet. So everything will be stored in this Cassandra database. Now we have discussed how we are going to store tweet in different data stores based on the tweet type. If that tweet contains video or image, then we will handle it separately, or we can say that we will store it separately. If that tweet contains tiny URL, then we will handle it separately. And let's say if that tweet contains plain text, then we will handle it separately. So till this point we have discussed how we are going to store that tweet in different data stores. Now this tweet ingestion service will generate a tweet ID, the tweet that user posted. So this tweet ingestion service will generate a tweet ID for that tweet, and then it will send this tweet ID to Kafka queue. Now here the flow of tweet ingestion will be over. We have saved the tweet to different data stores based on the type of tweet. So this tweet ingestion service is responsible for storing the tweet to different data stores. It does not provide any GET API, or we can say that it is not responsible for fetching the tweets. So this tweet ingestion is responsible for storing the tweets. Now we will be having this tweet service, and this tweet service will be responsible for fetching all types of tweet. It can be get tweet by tweet ID, get tweets by user ID. So all this data or all such API will be powered by this tweet service, and this tweet service is sitting on top of Cassandra database. So if a user wants to fetch tweets from a particular user, so he will simply use that query get tweet by user ID, so he will get all the tweets. And let's say if he wants to get a particular tweet, so he will use that API which is get tweet by tweet ID. So all such APIs will be powered by this tweet service. Now whenever someone's timeline needs to be generated, this is also powered by this tweet service. Now what is timeline here? So whenever someone wants to look at the tweets on a read flow, there are two kind of views that a person can have. First, they can have a user timeline, and then they can have home timeline. So let's understand both the timelines in a brief for better understanding. So first we will be having this user timeline. So you can consider this user timeline as a profile page of someone, profile page. So in this profile page you will see person's username, you will see all their tweets that they made, and you will also see their bio or their profile picture. So all such information will be provided by this profile page, and this profile page is known as user timeline here. Now one more thing we have, which is this home timeline. So in this home timeline you will see tweets made by all the persons whom you follow. So you can consider this home timeline as a home page. So it is very obvious, and you would have seen that when you open Twitter homepage or Instagram homepage, in that homepage you will see all the posts, all the tweets made by users whom you follow. So this is about our both the timelines. Now let's discuss how it works and how we can fetch someone's timeline, someone's home timeline, someone's user timeline. So in order to fetch user timeline of someone, we can simply do select star on Cassandra, where user ID is either your user ID or someone else's user ID. So it can be your own user ID or others user ID. Now let's say if you want to see your own profile, then you will provide your own user ID, and let's say if you want to see someone else's profile, then you will provide their user ID. So this is how we will create the user timeline of someone. Now how we will construct the home timeline. So home timeline will be constructed in this way: select star on Cassandra, where user ID is nothing but the list of your following, because as we have already discussed that home timeline will be the combination of all the tweets made by others, made by people whom you follow. So how it will be done and how we will create the home timeline. So first we will fetch all the following of user, then we will fetch their tweets one by one. Let's say we have 3 users, 1, 2 and 3. So first we will fetch all the users, then we will fetch their tweets. Let's say first we will fetch first user's tweet, second user's tweet, and then third user's tweet, and then we will arrange all their tweets and will create the home timeline. So it is a very naive and brute force approach, and making this query at runtime will end up slow down the things, because let's say if someone follows 1000 plus people, so in this case first we will fetch all the following, all the 1000 people, then we will fetch all their tweets, we will arrange them, and then we will create a home timeline. So it will take so much time and it will end up slow down the things. So we are not going to use this approach to create someone's home timeline. Instead we will cache some of the information, because as we have already discussed that Twitter is a very read heavy system. For every write there are 1000 people reading that tweet. So Twitter is a read heavy system, so we will pre-calculate some of the information or cache some of the information, because fetching 1000 people and then fetching their tweets and then arranging them and creating home timeline is not a good option. So what we will do, let's try to understand this with the help of example. So let's say here we have 4 users. Let's say user 1, user 2, user 3, user 4 and user 5. Now let's say we have this user 1, and this user 1 is followed by all the 4 users, u2, u3, u4 and u5. So all 4 users follow this user 1. Now let's say this user 1 posted a tweet. Let's say the post that he posted, its ID is T1. So this user 1 posted a tweet T1. Now how it will be fit in our architecture? So in order to understand this, let's go to our diagram. So here we have this diagram, and as we have already discussed that tweet ingestion service will send an event to Kafka. It will send tweet ID to Kafka. Now here we will be having this tweet processor service, and this tweet processor service will be responsible for making a home timeline. Basically it will help us to cache some of the information, cache someone's timeline. So this Kafka will send this tweet ID and user ID to tweet processor service. Now what this tweet processor service will do, so in order to understand this, let's go again here. Yeah, so we have this user 1 and user 2, user 3, user 4 and user 5 follow this user 1, and this user 1 posted a tweet with ID T1. So in this case we will make an entry in Redis that this is user 2, this is user 3, this is user 4 and this is user 5. We have already discussed that in Redis key will be our user ID. So here user ID is our key. So we have created entry like this in Redis. Now when this user 1 will posted a tweet, let's say this T1 tweet, so in this case we will simply, or we can say this tweet processor service will simply add an entry that for u2, for user 2 there's a tweet T1. So here we will add T1. Similarly for user 3, user 4 and user 5 we will add T1 tweet, because all the 4 users, this u2, this u3, this user 4, this user 5, all the 4 users follow this user 1. So here we are creating home timeline, because what these users, what all those 4 users will see in their home timeline, so they will see post made by others, or we can say they will see post made by the persons whom they follow. So this user 2 will see all the posts, all the tweets made by users whom this user 2 follows. Similarly for user 3, user 4 and user 5. So all the 4 users follow user 1. So they will see user 1's tweet in their home timeline. So this user 1 posted a tweet T1. So we will simply add this entry in Redis. Now let's say another user comes, let's say this u5. This u5 is also followed by this user 2. So let's say this user 5 posted a tweet, let's say T2. So in the home timeline of u2 we will see another tweet T2, and let's say here we have one more user, user 3, and this user 3 is also followed by this user 2, and let's say this user 3 posted a tweet T3. So we will see this T3 tweet in the home timeline of user 2. Now let's wrap up the things till here. So let's go to the diagram. So here this tweet ingestion service will send the tweet to Kafka. Then this Kafka will send user ID and tweet ID to the tweet processor service. Now this tweet processor service will use the fan out technique. So this tweet processor service will fetch all the followers of u1, let's say u2, u3 and u4. So this tweet processor service will fetch all the followers of u1. So in order to fetch all the followers of u1, this tweet processor service talks to this graph service. So you can see an arrow going towards graph service. Now this tweet processor service will fetch all the followers of u1. Then this tweet processor service will create the home timeline of all three users, this u2, this u3 and user 4, and it will add this t1 tweet in their home timeline, and then we will send this to Redis cluster. So this is what we did here. We are just storing these tweet IDs, different tweet IDs, to the home timeline of user, different users. So basically here we are caching the home timeline of different users. So we cached the home timeline of u2, we cached the home timeline of u3, we cached the home timeline of u4, we cached the home timeline of u5. So till this point we have stored this information, or we can say we have stored the home timeline of different users in the cache memory or Redis. Now let's say this user 2 wants to see what is present in the home page. So he will see all these tweets in his home timeline or home page. So let's say here we have the home timeline in this diagram. So in this home timeline, this user 2 will come. So here we will be having this user 2, and he will open the Twitter home page. So he will see home timeline. Now this request will first go to timeline service. This timeline service will go to this Redis cluster and will ask that, do you have the home timeline of user 2? Then this Redis cluster will say, yes, I have the home timeline of user 2. So it will return the home timeline, which is this. So it will return the home timeline of user 2 to the timeline service, and then timeline service will send this to the UI. So this user 2 will see the home timeline, or we can say it will see all the relevant tweets for his home timeline or for his home page. So we call this technique as fan out technique, fan out on write. Now, as we already discussed that Twitter has about 600 million plus monthly active users. So are you going to store the home timeline of every single user in the Redis? Actually not. We just cannot do this because Redis in a in-memory solution, and it is not good to store the home timeline of this amount of users in the Redis. So instead we will store the home timeline of only those users in Redis who are active. So as we have already discussed that we will be having two types of user. First one is active user and second one is passive user. Active users are the one who are accessing Twitter in the last 3 days, and passive users are the one who are not accessing Twitter in the last 3 days. So we are going to store the home timeline of only those users in Redis who are active in the last 3 days. So let's try to understand this with the help of example. So let's say here we have this user 1, and this user 1 is followed by u2, u3 and u4. Now let's say this u2 is an active user, this u3 is an active user, but this u4 is a passive user. So in the Redis we are going to store the home timeline of only u2 and u3. We are not going to store the home timeline of u4 in the Redis. So this is what I meant when I said we are going to store the home timeline of only active users in the Redis. Now, okay, we have covered the active users case, but let's say if some passive user came to our site, then how we are going to manage his home timeline? So in this case, let's say this user 4 came to our site. Now he want to see his home timeline. So he will make a request, and then request will interact with the timeline service. Now what this timeline service will do, it will fetch all the following of u4. Basically it will fetch all the people followed by this user 4. Now let's say this u4 follows u3 and u5. So this timeline service will fetch this user, and then this timeline service will send this data to tweet service, and it will say that okay, give me all the tweets of user 3 and user 5. Now this tweet service will query Cassandra database because it is a source of truth for all the tweets. So this tweet service will go to Cassandra database and it will fetch all the tweets made by this user 3 and user 5. Basically it will use that API that we discussed, get tweet by user ID. So it will use that API and it will fetch all the tweets made by this user 3 and this user 5, and then it will arrange all those tweets and will send this data to timeline service, and then this timeline service will send this data to the home timeline of user 4, and this timeline service will also store this data in Redis because this user 4 is become active now. So this timeline service will store this data in Redis as well. So it will store the home timeline of u4. Let's say that this u3 posted T6 tweet and this u5 posted T7 tweet. So we will add the home timeline of user 4 in the Redis, and we will add this entry T6 and T7. So this is how we will handle both the cases, active users case and passive users case. Now there's one more case. Let's say you have someone with 100k plus followers in Twitter. So how we are going to handle that case? So in order to understand this, we first need to understand why we just cannot handle a celebrity case in a same way, the way we are handling normal users. So let's try to understand this with the help of example. So let's say here we have a user u1 and he has 10 million plus followers. Now let's say we have 5-6 followers of this user. Let's say u2, we have u3, we have u4, we have u5, and we have u6, and it will go till 10 million. Now when this user 1 will post something, let's say this user 1 posted a tweet T1. Now in this case we will have to update the home timeline of all the 10 million users. We will have to update the home timeline of all the 10 million users. So is it good or is it okay to change the home timeline of 10 million users just for this one tweet? Actually not. It is a very bad thing if we are doing this. We just cannot update 10 million entries just for one case or just for one update. So how we are going to handle this case? So in order to handle this case, we are going to use slightly different technique. So let's say here we have a user u1 and he has 10 million plus followers. So he is a celebrity, or we can say he is a famous user. We have one more user. He is a normal user, and he uses Twitter every day. So he will be a active user. Now here we have 3 more users, u3, u4 and u5. Now let's say this user 2 follows all these users. This user 2 follows u1, this user 2 follows u3, this user 2 follows u4, and this user 2 follows u5. So the home timeline of user 2 will look something like this. So this is user 2. Now let's say this user 5 posted a tweet T5. So T5 will be added in the home timeline of u2. U4 posted a tweet T4, so T4 will be added in the home timeline of U2. U3 posted a tweet T3, so this T3 will be added in the home timeline of U2. Now when U1 will post, we will have to handle this case because this U1 has 10 million plus followers, so we are not going to update the entry of 10 million users just for one tweet. Now let's say this U1 posted a tweet T1. So how we will add this T1 tweet to the home timeline of user 2? So we have to handle this case. So in this case, we are not going to use that tweet processor. So let's discuss how we are going to handle this celebrity case and how we will add this T1 tweet to the home timeline of this user 2. So this user 2 will go to the home page and then request will go to the timeline service. Now this timeline service will see what all the people this user 2 follows. So this user 2 follows user 1, this user 2 follows user 3, this user 2 follows user 4, and this user 2 follows user 5. So timeline service will see this. Now amongst all these people, he will fetch what all the celebrities that this user 2 follows. So he will get to know that okay, U1 is a celebrity who has 10 million plus followers. So this user 2 follows this user 1. So he will fetch user 1. And let's say if there's some other celebrity that this user 2 follows, let's say user 6. So this timeline service will also fetch this user 6. Let's say he has 5 million followers. So this timeline service will fetch all these followers, and now this timeline service will send this data to tweet service. So you can see this in the diagram that this timeline service will query graph service just to fetch all the celebrities that this U2 follows. Then this timeline service will send U1 and U6 to the tweet service. Basically, this timeline service will tell to the tweet service that this U1 and U6 are the celebrities and they have followers in millions, and U2 follow both the users. So it will send this user ID to tweet service and it will ask that give me all the tweets of both the users. So this tweet service will go to the Cassandra database and it will fetch all the tweets of user 1 and it will also fetch all the tweets of user 6. So it will fetch all the tweets of both the users and arrange all the tweets, and it will send this tweet to timeline service. Now this timeline service will add their tweets. Let's say this U1 posted a tweet T1 and U6 posted a tweet T6. So this timeline service will have access to these tweets now. So he will simply add those tweets in the home timeline of user 2. So this is how we will add this T1 tweet in the home timeline of user 2. So we will simply add this T1 tweet and T6 tweet in the home timeline of user 2, which is present in the Redis, and then this entire timeline will be sent to user 2. So this is how we are going to handle the celebrity case. Slightly different, but the intuition is simple, that we are not going to overload Cassandra database and we are not going to overload Redis cluster. So this is pretty much for this timeline service. Now let's discuss about how user will be searching a particular user, how we will search a tweet, and how this trend thing will work. So for this we are going to have this search UI. let's say a user wants to fetch a particular tweet, or user want to search about a particular user, so he will make a request through this UI. Request will interact with the load balancer, then this request will go to search service, and then the search service will query Elasticsearch cluster for user's request. Now why we are using Elasticsearch cluster here? Because Elasticsearch cluster provides the functionality of fuzzy searching and auto completion. So let's say if a particular keyword is trending and user just provided 2-3 characters of that, so it will start suggesting that trending keyword. So this is the reason we are using Elasticsearch cluster here. And this Elasticsearch cluster will offer both the APIs, get request and post request. Basically, whenever a new tweet will be added, this tweet ingestion service added this tweet to Kafka. Now this Kafka will send this data to search service, and the search service will store this data in Elasticsearch cluster, so that people will come and fetch all the tweets related to the keywords or hashtags. So this Elasticsearch cluster offers both types of APIs, get API and post API. So this is pretty much for the search service. Now let's discuss how trends work in Twitter and how we are going to calculate trends. So in Twitter, you would have seen that whenever a special event occurs, let's say India lifting the World Cup, Donald Trump winning the election, Donald Trump Elon Musk fight. So whenever all such events happen, some keywords start trending. Let's say hashtag World Cup, hashtag election, hashtag India, hashtag Elon Musk, hashtag Donald Trump. So all such trends, all such keywords start trending. So how it happens and how we calculate trends. So let's try to understand this with the help of example. So let's say someone uploaded a tweet. Let's say Donald Trump uploaded a tweet. So this tweet will first come to this tweet ingestion service. Then this tweet ingestion service will send this tweet to Kafka. Now this Kafka will further send this tweet to filter operator. Now what this filter operator does, so let's try to understand this with the help of example. So let's say Donald Trump posted a tweet with the hashtag election and hashtag win. So first we will discuss what is the work of this filter operator. So he posted a tweet with these hashtags and these keywords. Now there are 3 more people, let's say user 1, user 2 and user 3. They also posted a tweet with hashtags, hashtag fun and hashtag food. So in this case, let's say we have already discussed that Twitter is a write heavy system in which 6,000 new tweets come to Twitter every second. So let's say amongst all those 6,000 tweets, 3,000 tweets contains hashtags like this, hashtag fun, hashtag food, which is very common hashtags. So you just cannot put all those common hashtags and entertainment purpose hashtags to trending list. So we are not going to put all those hashtags and keywords in trending list. But when Donald Trump will post something, when Donald Trump will use hashtags like this, hashtag election, hashtag win, so these keywords and these hashtags will start trending. So what this filter operator does, it will identify that okay, what are the hashtags. So it will see, in this case it will see that okay, both the hashtags are very common and people use such hashtags every day. So this filter operator simply discard that entire tweet from the pipeline, that this tweet is never going to trend. So he will simply discard that tweet and will remove that tweet from the pipeline, this pipeline that we can see here. So every tweet will go to this pipeline. It will go to tweet ingestion service, Kafka, filter, parse. So this filter operator will simply discard that tweet from the pipeline if it doesn't contain any trending hashtag. Now, if that tweet does not contain any common hashtags and common keywords, then this filter operator will further send this tweet to parse operator. Now this parse operator will do two things. If okay, let's try to understand this with the help of example. So let's say Donald Trump posted a tweet with these hashtags, hashtag election and hashtag win. So this parse operator will do two things. If that tweet contains hashtag, then it will extract the hashtag. And let's say if Donald Trump posted a tweet and that tweet does not contain any hashtag, so in this case this parse operator will simply create hashtags using those keywords that are mentioned in the tweet. So this parse operator does these two things, and we are going to use Spark streaming as a parse operator. Now after doing this, parse operator will simply send all the hashtags to two different pipelines, first for geolocation and second for count tags. So let's discuss a little about these pipelines as well, what these pipelines are doing and why we are sending hashtags, trending hashtags to two different pipelines. So first, this parse operator will send tweets, or we can say it will send hashtags to this pipeline. In this pipeline, this count tags operator will simply count all the hashtags, common hashtags, let's say hashtag election, hashtag win, and it will also find some other similar hashtags, and then it will send these hashtags to rank operator. Now this rank operator will decide which hashtag is going to trend, so it will provide rank to different hashtags, or we can say it will create groups of hashtag. In one group it will put all the similar hashtag, and in another group it will put all the similar hashtags. Then it will rank those hashtags. It will provide rank to those hashtags. So this is how we are going to calculate trends. Now it might be the case that some of the hashtags are only specific to a particular location. Let's say there's an election happening in Pakistan, so other geographies might not be interested in that. So that hashtags, hashtag election, hashtag win, and candidate's name, so all such hashtags will be trending in the Pakistan only. So this is the reason we are going to use this another pipeline, which is this geolocation. So we are going to send hashtags to this pipeline as well, in which we will be calculating in what all the geographies, what all the hashtags are trending. So this geolocation operator will calculate this, and then it will calculate all the hashtags, and similarly the way we did here, we will provide rank to different hashtags. So here also this count operator will count tags, similar tags, and then it will provide rank to different hashtags. And this is how we are going to calculate trends for a particular geography, and then we are going to send everything to this Redis. So we will be storing everything in Redis. So yeah, this is how we are going to calculate trends, and this trend will be calculated in a particular window, let's say a 5-minute window, or we can say a 15-minute window. It can be a 1-hour window. So this Twitter will identify that what all the hashtags and what all the keywords are trending in a particular window. Let's say if a particular hashtag or similar hashtags are trending continuously for 3-4 hours, then Twitter will identify that okay, this might be a trending keyword, so it will process all those hashtags. They will be used by different operators, and then we are going to rank all those hashtags, and then we will put them into Redis. So this is how we are going to calculate trends, and this is pretty much for the system design of Twitter. Now I hope you have enough understanding of this diagram and all the tech jargons that are mentioned here. And yeah, this is pretty much for the system design of Twitter. We'll see you in the next video. So till then, bye bye, show some love, thanks.